Okay, sebelum kita mulakan kelas, before we start our class today, so I would like to recap some of the point that we have learned last week. So ada sesiapa yang boleh ingat kembali, nyatakan semula apa yang awak dah dapat daripada kelas minggu lepas. Apa konsep yang awak dah dapat from the previous class?
Doctor,
Yeah.
last week we learned about number system and then how to convert the numbering system, for example, binary to hexadecimal.
Binary to hexadecimal. Okay. Thank you very much. So the main things, the main point, the main things that we have learned last week is about the number system. We start from the decimal number, which contains of 10 digits. So that is why we call it as a decimal in the scientific terms, or perpuluhan, the other name for the system. Okay, and then we have the octal system. The name came from the number of digits in the system, which is we only have 8 digits starting from 0 to 7, without 9 and 10, without 8 and 9. And we have apa nama hexadecimal, which consists of 16 digits starting from 0 and F to F. So both octal and hexadecimal is just for the example what would happen if the digit is less than 10, and what will happen if the digit is more than 10. 10 is our foundation lah. The basis of our system is 10 digits lah. This is the system that we use every day. So this is the foundation, the basic. And the octal is just for the example, what is going to be happen if the system is the digit in the system is less than 10, and hexadecimal is what going to happen if the digit is more than 10. And there are one more number system which is known as binary. Binary means 2. So we only have 2 digits in the system starting with 0 and 1 and continuously with the sequence of 0 and 1. And the sequence of 0 and 1, we create this sequence based on this table. The this orange table where I ask you to memorize the sequence 1, 2, 4, 8, 16, 32, 64, and 128. Because from this sequence, we can create the numbers lah. For example, if 3, we need to use 1, 1. 1, 1 means that 2 plus 1 is 3. If you want to create 4, it is 1, 0, 0. 1, 0, 0 means 4. Means we use 4 without using 2 and 1. So we start the number from right to the left. So that's why we use, that's why the rest of the number to the left side, we just ignore it if we are not using it. But the sequence to the right side, we will use it if you want to create a combination of 0 and 1. Okay. So this one is the this is the example. The blue table here is the example just to differentiate why the sequence where do we got this sequence. Okay, so I give one example here, 25 base 10, which is the number in decimal system. So actually the base or the sequence, we also have a sequence for base 10, which is starting from 10 in power of 0, we got 1. 1, okay. And then we have 10 in power of 1, which is 10. and then we have 100, 1000, and so on. So the concept is similar. The binary concept is similar like decimal, where each of the digits has its own value. Okay, so from right to the left, it has its own value. Similar goes to the decimal number. So example here, I give you 25. So 25, we got 25 from the combination of 2 times 10 plus 5 times 1. So 20 plus 5 is 25. So that is how 25 we apa? That is how we get the value of 2 and 5, 25. So that is the, okay, before that, we end up the last class with how to convert the binary to the binary to decimal, as well as how to convert decimal to binary using specific technique lah. This is the first technique. I put the color here. So the green one, okay, so the green one is technique to convert the binary to decimal, and the other one I put this as a purple one. Allah tak nampak as a yellow one. So the yellow one represent the technique how to convert decimal to binary. So it is vice versa. The green one we use time multiplication, and the second one we use division. Okay, so that is some of the things that we have learned last week. So before we proceed for this week content, so if you have any question regarding to the last topic, so please ask me now. I'll give you about around 5 minutes to ask me any question regarding to the previous number system, especially binary and decimal. Mungkin ada apa-apa soalan tentang kenapa kena belajar ke apa-apa yang out of the topic. Maybe you want to ask me about not about the technique how to convert. Maybe you have another anything that cross into your mind. Maybe you want to ask me why we need to learn about the system numbers, the number system, or anything. Ataupun sampai mana hadnya mungkin you nak tanya sampai mana nombor yang kita nak belajar, maybe?
Doktor nak tanya boleh?
Boleh.
Sebenarnya saya keliru bahagian yang hexadecimal tu. Sebab minggu lepas kan doktor ada bagi contoh macam mana nak dapat 11 kan?
11.
Boleh tak nak terangkan semula? Minta doktor terangkan semula.
Sekejap saya bagi contoh untuk dapatkan 11.
Untuk hexadecimal.
Hexadecimal.
Hari tu saya tengok video doktor minta buat nombor 11. Macam mana dapat nombor 11 untuk hexadecimal?
11 untuk hexadecimal. 11 maksud awak 11 decimal ke?
Sekejap saya balik.
Saya pun tak ingat soalan tu. Dalam nota ni tak ada pula.
Maksudnya untuk menghasilkan 11, F tambah 2.
Oh, itu dah masuk operasi tambah. Itu
Okay.
dah panjang sikit. Nanti memang kita akan sampai pada topik berkenaan, tapi kalau nak tahu buat masa ni boleh juga, tak ada masalah pun. Okay, so untuk dapatkan 11, how to get 11 using hexadecimal. Okay, this is the sequence of hexadecimal starting with 0 to F. Okay, saya faham soalan awak tu. Okay, actually dia macam ni Okay, bear in your mind, okay, put in your mind, keep in your mind that F is a system, the number system that has 16 digit. Okay, ini yang kita dah belajar untuk hexadecimal. Okay, go back to the basic, the concept, the foundation of the numbers of digit. Balik kepada decimal. Why we go back to decimal? Because decimal is this the number system that very familiar to us, because we use number using decimal. So that's why kena patah balik to decimal. Baru kita faham konsep yang seterusnya. So in the decimal, we have 10 digits, starting from 0 to 9. After 9, the sequence start by pairing each of the digit continuously, starting with 1 and 0, 1 and 1, 1 and 2, and 1 and 3, until 1 and 9, until we repeat again 2 and 0, 2 and 1, 2 and 2, until all digits are used to create the number. So the last digit, the last number for 2 digits is 99. So this is the sequence. Nombor ni memang dah standard. So from this sequence of number, we are going to do add. We are going to manipulate this sequence by using arithmetic. Tambah, tolak, darab, bahagi. That's the basic of mathematics. Okay. If you want to learn about mathematics, the first thing is digit lah, because we need to use digit in our calculation. And then after we know about the digit, we learn about the process or the things that we can do on that numbers. So the basic thing that we can do on that numbers is arithmetic function lah. Arithmetic function such as tambah, additional, subtraction, multiplication, division. So in this class, we are not we only learn about additional and a bit about subtraction. No division, no multiplication. Okay. So it's easy tambah dengan tolak aje. Okay, so we start with tambah because your friend question just now is about additional process. Okay. As we know, if you use decimal number, okay, 4 campur 2 is 6. 4 plus 2 is 6. Because we need to jump 2 step forward. 4 and plus 2, 2 forward, 2 step forward. So we got 6. Okay. If we were 9 plus 2, 9 plus 2 means we jump 2 step forward. 9 plus 1, 10, and plus 1 more step, 11. So this is the first arithmetic process, which is known as additional process, where we manipulate the sequence of decimal number for this purpose lah. Okay, go back to hexadecimal. This is the sequence of hexadecimal. Okay, the idea behind the sequence of number, if after the digit is finished, what can we do to prolong the sequence?
10.
We need to combine the digit, right? Itu konsep dia, kita combine digits, similar like decimal. So we combine 1 and 0, and we name it as 10. 10 is a combination of 1 and 0. The basic cell ataupun atom lah, nombor yang digit. The size of the numbers, the smallest size of the numbers is the digit. I mean the properties of the numbers. So 10 is a combination of 1 and 10, and followed by 1 and 1, 1 and 2, 1 and 3, 1 and 4. Listen to the way how I speak that numbers. Okay, I just mentioned 1 and 0, 1 and 1, 1 and 2, 1 and 3, 1 and 4. Okay, I never use 10, 11, 12, 13, 14. Saya tak guna perkataan 10, 11, 12, 13. Saya guna perkataan 1 dan 0, 1 dan 1, 1 dan 2. Listen to the words that come out from my mouth. Sebab sebutan tu penting. The way how we mention the numbers is very important because it shows how we understand about the numbers. Okay, kalau sebut 1 and 0, it means 10 is a combination of 1 and 0. If you say 10, you know the number is 10, but the detail, the properties of 10, I don't know whether you understand it or not. So for this class, we go to the basic element of the number, which is digit. So after we got the sequence, the way how the number is represented, I mean the sequence, macam mana ia terbentuk, how the number is created, and then after we know about the concept, and then after that, we can learn about how to manipulate the sequence. So to manipulate the sequence, we use the arithmetic process. We have tambah, tolak, darab, bahagi, additional, multiplication, subtraction, division. And again, in this class, we already cut out division and multiplication. It only left tambah dengan tolak. So mudah. Only left additional and subtraction. So for the additional process, again, like similar like decimal, if we have 4 plus 2, 4 plus 2 means 4 and plus 2 step ahead. So 4 plus 2 step. 5, 4 to 5 is one step, 5 to 6 is the second step. So 6, 4 plus 2, 4 plus 2 is 6. So similar to 9. If we add 2 to 9, so we need to add 2 steps. So 9 plus 1 step. One step is A, the second step is B. So 9 plus 2 is B. So back to the question just now, how can I get 11 from F plus 2? Because we step 2 step ahead. We take 2 step ahead. F plus 1 is 10, plus 1 more is 11. As easy as that. Clear tak?
Okey, dah faham dah. Terima kasih Doktor.
Very simple sama-sama. Okay, ada soalan lain lagi? Any other questions?
Doktor, ada yang nak masuk kelas tapi tak dapat approval lagi.
Okay. Okay, sudah saya approve. Any other questions? The point here, I just want to to make sure that you guys know how to create the numbers from the given set of digits. Let's say I ask you to create a sequence of number for pental system. Pentals mean 5. So we only have 5 digits. So what is the sequence of number for 5 digits? So 0 to 4. Starting from 0 to 4 for the single digit. And for the for the double digits, again we start with a combination of 1 and 0, 1 and 1, 1 and 2, 1 and 3, 1 and 4. And then 2 and 0, 2 and 1, 2 and 3, 2 and 2, 2 and 3, 2 and 4. And then 3 and 0, 3 and 1 is repeated until what is the last double digit for pental? And anyone can answer me? Pental is 5. So what is the last 2 digits numbers?
5.
Be careful be careful. Okay, dalam kelas saya ni be careful sebab nombor start dengan kosong. The number start begin with 0. So if I said 5 digits in the pental system, so the first digit must be end with what number?
4.
4. So the last 2 digits number for pental is what number?
4.
44. Yang ni kena beri perhatian. Please give some perhatian to this point because a lot of students make mistake because if I say pentals mean 5 is starting from 0 to 5. So it's wrong. 0 to 5, it means 6 digit, not 5. Please remember this. Starting from 0 is a number. 0 is a number, but yes, 0 is a number, but it has no it has no pair. For other numbers, they have pair. They have pair like 1 you have -1, 2 you have -2, but 0 we don't have pair. So it's a special orang kata we need to do anything we do to this 0, it must be in a special scope. Dia tak boleh sama dengan orang lain. It can't be similar like other digits. So that's it. So it's the sequence of number and how we manipulate that number. Okay, now and then we have binary. Binary ni kalau nak create dia, we need to memorize lah this sequence. Okay. Sama juga kalau you tak nak ingat this sequence, if you don't want to memorize this sequence, use the similar concept, the combination of digit. Let's say 1 and 0, and then the number is 1. After 1 is 1 combined with 0, and then 1 combined with 1. So 11 is the last digit. The last number for 2 digits in binary is 11. 11 is in binary. In decimal is 2 plus 1. We use this sequence. 2 plus 1 is 3. So 0, 1, 2, 3. And how to make up 4 using binary digits? Similar, use the same concept. We combine 1 with 0 and 0. Okay, and then 1 with 0 and 1. Combination, 1 with 0 and 0, or 10 lah, 10 here, 0, 1, 0, 1, 0, we combine with 0, and then 1, 0 with 1, and then 1, 1 with 0, and then 1, 1 with 1. We keep on repeating the same thing. So what is the next, okay, yeah, I delete this first. So what is the next numbers? What is the next numbers after 111?
1,000.
Combination of 100 and 0. And then sebutan tu dia betul lah sebab actually I just want to hear you guys said a combination. So 100 combined with 0. Macam tu. Konsep tu penting. Okay, what is the next number after 1000?
100 combined with 1.
100 combined with 1. And then proceed. After 100, we have what? Okay, 101, 011, 101 combined with 0
Zero.
dulu lagi.
Zero.
Combine dengan 0 dulu. Lepas tu 101 combined with
1.
1. And then the next number
111 combined with 0.
okay, and then
111 combined with 1.
okay, so you see here all digit is 1. So means this is the last digit or the last number for 4 digits. Nombor terakhir untuk 4 digit. Sebab semua dah pakai ni 4 digit. All ones. Okay, how to check are this correct or wrong? This code is correct or wrong? How to check it? Okay, 0 is 0, 1 is 1. Then 10, 10 is 2. Use this table. 1, 0. So 2 plus 0 is 2. So correct. This one is 2. So this one is 3. Okay, 2, 1, 1, 1, 1 mean we use 2 and we use 1. So 2 plus 1 is 3. 100, 100 is 4. Is it correct or wrong? 1, 0, 0. So 4 plus 0 plus 0, which is 4. This one is 5. 5 is 4 plus 1. See? 4 plus 1. So we use 4 and 1. We are not using 2 because it is 0. So this one is 5. Correct. So this one is 4 plus 2. This one is 4 plus 2 plus 1, which is 7. This one is 8. 100, 1, 0, 0, 0. So it is 8. And then this is 9. Then 8 plus 1. This one is 8 plus 2, which is 10. And then 8 plus 2 plus 1 is 11. And then 8 plus 4 plus 2 is 12. And then 8 plus 4 plus 2 plus 1. Kejap. 10, 8, 9, 10, 11, 8, 9, ada salah kat sini. Kejap. 8, 9, 10, 11. 12 is 1, 1, 0, 0. 1, 1, 0, 0 tak ada lagi. 1, 1, 0, 0 is 12. And then 13, 1, 1, 0, 1. Kita lompat banyak. This one is 13. Skip banyak number. We have skip a lot of numbers. 13 and then we have 14. And then we have 15. So we miss 3 digits, 3 numbers. Ni kita terlepas tadi. Kita terlupa ada 11, kita tak combine lagi. Okay, dapat tak yang ni? Any questions about the binary sequence of numbers? Kalau tak faham tanya. Okay. Kalau tak ada soalan, okay. Okay, last week we stopped at how to convert or how to relate decimal to binary to decimal and decimal to binary. So for today, decimal, binary, binary, decimal. Okay, for today we learn about how to connect or how to relate hexadecimal and octal to binary and to decimal. Sorry, okay, to binary and to decimal. So let's say we have satu nombor, we have a number. Let's say we have a number. Okay. Ini contoh yang seterusnya. Let's say kita ada 7, 1. For octal number, for octal, this example is for octal number. So, example. This one example. Okay, let's say we have 7, 1, 6, base 8. Base 8. Don't forget to write like that. Base, it represent the numbers. The numbers is in apa nama octal. So there is no 8 and no 9. Let's say if the number is 719, what should you do if you got this kind of numbers? What you can say about it? Invalid, invalid because there is no 9. I nak ajar you cara bagi justification. You boleh ajar orang. Belum jawab soalan, you tahu dah. This one is invalid. Why? Because it has 9. Settle. Tak payah jawab kalau ada soalan. No need to answer because it is invalid. Okay. But I change this into the valid number. Let's say 716. So how to relate this number to binary number? Kenapa kita nak relate to binary? Because computers speak in binary language. So we use the same technique how to convert decimal to binary. So we use division technique here. Division technique. But instead of divide 716 with 2, okay, kita tak bagi dengan 2, kita bahagi dengan kita bahagi dengan sekejap nak bagi dengan 2. 8 bahagi 2. 1, 2, 3, 4. Ada teknik sekejap Tak ada teknik ni, kita guna teknik. Okay, the technique that we use to convert octal to binary is by using this apa nama ni 1 digit is equal to 1 digit octal equal to 3 bits or 3 binary digits lah. Binary digit ataupun 3 bits. 3 bits. Okay. So what does it mean? It means, okay, what is the step that you can do is 7, 1, and 6. So we represent all of this digit with 3 bit. Ini binary, ini octal to apa nama binary Okay. So how to represent 6? You start from right to left. So how to present 6 using 3 bits? Mana nak bentuk 6 daripada 3 bit? 3 bit ni maksudnya kita guna bit lah, binary digit. This one is binary sequence. So how to create 6? What plus what?
4 plus 2.
4 plus 2. 4 plus 2 plus 0. Ingat nombor belakang kena ambil bila you sebut, you kena sebut belakang juga. So kita start from back side, belakang ni, bahagian belakang. So 4 plus 2 plus 0, so it's 6. So we are using 4. So we are using 4, we are using 2, we are not using 1, so it's 6. So how to convert represent 1 in binary using 3 bits? 3 bits, 3 bits. So 0,
001.
001, 001. And how to represent 7?
111.
111, 4 plus 2 plus 1. So 4 plus 2 plus 1 is 7. Macam tu. So this is the way how we convert octal to binary. So don't forget to write base 2 at the end of the sequence lah. Okay. Tengok cara saya menjawab soalan ya. So dalam exam, make sure you do this all of steps. Do not skip. Okay, do not skip the steps. Okay, just put 2 here. So it means the number is in binary lah. Okay, this is the way how we convert octal to binary. Okay, and then how to convert octal to decimal. Let's say we use the same numbers. Octal to decimal. Tolong record siapa yang ada di situ. Tolong record kelas hari ini. Nanti pas pada saya upload dekat My Guru. Okay. So, how to convert octal number into decimal. Okay, this one we use the 8 to decimal Kita guna kaedah bagaimana untuk any numbers that you want to convert to decimal, we use multiplication technique similar like this. Any number to decimal, let's say from binary to decimal, we use this technique. So same goes to octal to decimal. So I just copy this one, I put it here, and then I just replace this one with 7, this one with 1, and this one with 6. Sama je. So I replace the digits and the base. We use 2 here because it is the number binary to decimal from previous question. But now we want to convert octal to decimal. So please use base 8. Jangan guna base 2 pula. Base 2 binary to decimal. This one is base 8. Macam tu. So 8 kali 8, 64. 64 kali 7 berapa? 64 times 7.
448.
448 plus 8 and then plus 6. Tambah 6 sebab 8 and power of 0 is 1. So 1 times 6 is 6 lah. Okay. So 448 plus 8 plus 6. 4, 5, 6, 2. Berapa tadi?
Dr. 462.
462. 462 485 456 okey 462. So base 10 base 10 okay. So this is how we calculate convert octal to decimal So we only convert it to binary, we already convert it into decimal. Okay, how to convert it to hexadecimal? Later I will show you because we need to learn about hexadecimal first and then we can convert lah from octal to hexadecimal. But now at this stage, it's enough for you to know that how to convert, how to relate octal to decimal and binary. And then of course, after we learn about these two techniques, we can return to the previous system, which is for example here. So this is the example for octal to binary. So what if we want to convert it, reconvert it to apa nama octal? Okay, for binary to octal, let's say this is the question. So we just divide this sequence of number into a group, which is consists of 3 bits each group. Let's look how I do it. So starting with right side, don't start with the left side. Okay, remember that. Start with right side. So you take 3 digits here, put it away. We group it 3 by 3. Starting from left side, right side. Sorry, starting from right side, remember that. Okay, and again, 3 bits for 1 digit. So automatically we will get this, which is 7, and then 1, and then 6. 716. 716. Do this step jangan lompat-lompat, do not skip. Make sure your writing, it's easy for other people to understand your writing. So do it step by step lah. Berapa tadi? Asas 8. This 8 Okay. I know you can change this, you can do all this using calculator, but do remember that in my class, I would like to teach my student the concept of number. Calculation without using any device. So this is how we convert both, one system to another system manually without using calculator. Okay. So, okay, and then how to convert decimal to octal? So we use this one lah. Decimal to other number, we use division technique. So we use this technique for this one. Okay. Apa ni? Tak boleh pula. Okay. Saya jawab in sequence dalam bentuk group. So jangan campur-campurkan kefahaman awak. Saya ajar ni step by step. So after this one. After this one. So jangan confuse. Now we have, let's say we have 462 in decimal. You want to relate it or change it into octal. So we use the similar technique with this one, the yellow one, which is decimal to binary. but now decimal to octal. So if binary we divide by 2, so for octal we divide by
8.
8, divide by 8. By 8, and then where the number is 4, 6, 2. Okay, jom buat sama-sama. 4 bahagi 8, right? Decimal to, betul lah. Okey, tak apa, kita buat dulu. Kenapa macam besar je nombor ni? Sekejap Oh sorry, bukan 462. Astaghfirullahalazim. Okey, 462 bahagi 8 berapa? This number is quite big Biasanya kecil je nombor saya bagi, tak apalah. 462 bahagi 8 berapa?
57.75.
57.75 57.75. Sekejap, 57. Sekejap Okey, sorry, 462. Macam tu So 57.75. Okey, point. Kita tak kira point Sudah darab balik 57 kali 8 berapa? 57 times 8.
456.
462 tolak 456.
6.
6. Okay. So 57 times 8 plus 6. We will get 462 So ulang balik 57 kali 8 campur 6 kita akan dapat 462. Balance ni tak cukup tak cukup 8. That's why kita jadikan the balance Dia tak ada point. So 57 bagi 8, 57 divide by 8.
7.
7 kali 8.
Ada baki. Ada baki 1.
1. So 7 kali 8, 56. 56 campur 1, 57 Okay, 7 bagi 8, we cannot divide this number because it is sifar.
Baki 7.
The balance is 7. So 7. So read from here. Kejap, mana nak pandang? From. We read from here to mana tadi? Okay, this one from here to here. This is how we read it. So we got 0716. 0716. So 0716. Base 10. Base 8. So for 0 here we can ignore it lah. We can ignore it. So can we delete it Okay. So again we can get back the value here So we can check lah. From octal to decimal using this technique we got 462. And then 462 we use this technique we can get back 716. So it means the representation is correct. Sebab betul lah ni kena duduk. So we can recheck We can recheck the answer. So similar like this one lah. We can recheck the answer Okay, so at this stage we have learned about how to convert the relationship or the connection between octal and binary as well as octal and decimal. So that's it. This one is for octal. Okay, for hexadecimal. Hexadecimal to binary dengan hexadecimal to decimal Senang je kita copy ni balik. The technique is still similar. Copy ni balik. Nanti I buat color lain lah. So it means this one is one part lah. This one is one part Decimal to binary and octal to binary and octal to decimal. Okay, so this is for example. And then for hexadecimal. Okay, for hexadecimal, we start with, let's say we have 716. 716, apa nama, kita guna nombor yang sama ataupun 71F lah. 7, nampak pelik sikit base 16. Okay. To convert apa nama hexa to binary, okay, the formula is 1 digit hexa is equal to 4 digit. 4 digit So let's say we have 71F. Okay, so we represent this with 4 digit or 4 bit. So F is 15, 1 plus 1 plus, alamak, saya tersebut pula. So what is the representation of F in binary? F in binary. Remember, 1 digit is equal to 4 bit. So this one is 9 is 1001. And then this one, apa dia? Selepas 1001. After 1001 is 1010. So A is
1010.
Okay, 1010. It means 10 lah, 10. Tapi 10 dekat sini bukan 10 yang ni this 10 is combination of 1 and 0. The combination of a digit 1 0 1 1 1 2 1 3 1 4 until 1F until FF, something like that. But 10 here means the value. The value A2 is 1010 So F is ni 10, ni 11, 1010. This one is 12, 1100. And then we have 13, 14 and 15 in decimal. So 15 is, how to create 15 from this sequence? 1
1 and 1.
1 and 1. How many 1?
4.
4 1.
4 1. So 4 1 is F. So 4 1 is F. So this one is 1 1 1 1 1. And then 1, how to present 1 using 4 bit? Senang je ni. Ini 3 bit. Kalau 4 bit jadi apa?
0 0 0 1.
0 0. Tak dengar. How to present 1 using, how to represent 1 using 4 bit?
0 0 0 and 1.
0 0 0 1. Okay. 7.
0
0
1 1.
1 1 and 1.
Okay, setelah selesai. So this is the answer for apa nama hexa to binary. Senang je Teknik dia macam ni je. This is the technique, as simple as that Tak payah darab, tak payah bahagi, apa pun tak payah. Kosong, 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 kosong. Satu, 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 satu. 4, 1, 1, 1, 1. 0, 0, 0, 1, 0. Okay. So this is the representation of binary for 71F hexa. Okay. Now, of course, we return back to the from binary to hexa. Sama juga Let's say we have these numbers. We have this number, let's say. Okay. Sama juga, we divide this number 4 by 4. So we have 4, 4, 1, 1, 1, 1 here. And then we have 0, 0, 0, 1 here. And then we have 0, 1, 1, 1 here. So we do that 4 by 4 and then we will get 7, 1, F. So the answer is 7, 1, F. Okay, selesai. This is hexa to decimal, hexa to binary and binary back to hexa. Okay, let's say we have the same numbers. Mean 71F in hexa. So how, okay, try to get the representation of decimal for this number. Cuba bagi tahu saya apa yang perlu saya buat untuk dapatkan perwakilan dalam decimal. Saya akan ubah daripada sini saja, step yang ada di sini ya. Okay, tunjukkan saya. Just say it, I will write it for you. Nak buat apa dulu?
Lapan tu semua tukar 10.
8 tukar semua 10. Okey. Tepat tak 8 tukar kepada 10? Dah ada dua teknik ni. Ini teknik untuk binary kepada decimal dan decimal kepada binary. Awak tengok darab dengan apa, bahagi dengan apa. Okey. And then yang bawah ni octal kepada binary dan binary, octal kepada binary dan binary kepada octal, as well as octal kepada decimal dan decimal kepada octal. Tengok teknik apa yang saya gunakan. Okay. And then dekat bawah ni, okay, saya tunjukkan teknik octal kepada binary dan binary kepada octal. And now I have one left here. So nak gantikan dengan apa ni? Nak ganti dengan apa ni? 10 ke berapa?
Sixteen.
16. Kenapa 16? Sebab nombor kita gunakannya adalah dalam asas 16. Sama juga macam ni. Yang atas ni tadi, tengok saya guna 8. Sebab nombor asal dia dalam perlapanan. Yang ini, saya guna 2. Sebab nombor asas dia dalam 2. Perduaan. Yang kuasa-kuasa ni semua adalah nilai kedudukan digit. So nombor asal yang ni, so nilai kedudukan digit dia ni lah asas 2. So yang ni asas 8. So nilai setiap digit ni 8 So yang ni 16 lah. So bila masa nak guna 10? Nak guna 10 bila kita convert decimal kepada decimal. Bunyi macam kelakar kan? Kita ambil satu contoh Ni saya tolak ke bawah sekejap. Ni contoh saja ya. Katakan saya ada 719 dalam desimal. Dalam desimal. Sebab tadi ada kekeliruan kan? Macam lama baru nak dapat jawab. Kita nak darab dengan base berapa kan? Okay, let's say kita ada 719/10. How to convert this number to decimal? Maksudnya decimal kepada decimal. Macam mana? Kita darab lah. Ini logik logik. Ni just want to create your logic. Kita nak trigger awak punya logik je. 7 kali berapa?
10.
10 kuasa 10 kuasa
Kosong.
Dek, 7 ni kuasa berapa? Takkan kosong kot.
Wah.
2 pandai. Okey, 2 pandai pun. Alright. Lepas tu what comes next? 1 times
10 kuasa 2.
apa kuasa 2 lagi, Dek?
Kuasa 1.
Kurang lagi. Pandai kuasa 1. Kurang lagi. Atas ni kan makin berkurang. Kan, betul tak? So kita berkurang lah. Okay. And then 9 times berapa?
10. Kosong.
12 kosong.
Kuasa kosong. Pandai. Okay, times 10 and power of 0. Okay. 10 kuasa 2 berapa? 10 kali 10. 10 10 kali 10 kali 7. 10 kali 10 berapa? Dik, 10 kali 10 dik.
700.
100.
Itu 10 kali 10, 100 apa 700 pula.
Kali 7.
Macam tu kan. Buat step by step. Ini saya tunjuk contoh ni, I show you this example because some of you guys confused what we should put here, times with what. Tadi ada jawab ni times with 10 kan. So logically it's wrong lah. Kenapa salah ni? This is why. This is the reason why it's wrong. I show you the reason ya. So this is the reason. Because we familiar with decimal, so I use decimal lah. Nilai kedudukan digit the value of the digit lah. 1. Kan kita dapat 700 tambah 90 tambah 1. 1 kali 10, 10 7, 1, 9. 9 kali 1, 9. So, kita dapat 700 berapa? Hujan ke? Tak ada suara. Sini hujan lebat ni. Hello.
719.
719, pandai. So, nampak tak logik dia? Kenapa kita kena guna kuasa 10 dekat situ? Maksud saya kenapa kita kena... Yeah, so why do we use 10 here? So, because the number here is 10, base 10. Itu logik yang saya nak awak tahu sebenarnya. Macam ni asal 16, sebab logik dia 71F dalam 16. Boleh compare kenapa macam ni kan, 8 kepada oktal kepada decimal, I use 8. See, dia mesti ada ubah. Kalau ubah sistem nombor, dia mesti something yang you need to change if you use another system number. So ni saya padam balik, ni logik saja. Ini tak ada kena mengena dengan soalan tadi. This question has no relation with previous question. This is just for example, peneguhan example why we use times 10 here. Okay, so I delete this. So now we have 462, and then 462 in decimal, we want to convert it into hexadecimal. Okay, what should we do? Divide by. Kenapa soalan dia sama macam tadi? 6, tak darab lagi sorry. 16 kuasa 2 kali 7, 16 power of 2 times 7. Dapat berapa? 16 kali 16 kali 7.
1792.
1792. This one. Plus 16.
16.
And then plus 6. So dapat berapa? 1792 plus 16 plus 6.
1815.
This number is quite big for an exam. Smaller lah. This number that will be given is smaller than this lah, because my objective is I don't want you guys to use calculator. So use it manually. And for this case, the number quite big, so don't worry. Bila besar tu maksudnya tak ada lah dalam soalan exam. So this kind of numbers, the size. So now we go back from decimal to hexa. So let's say we have 1814. So divide by what? Divide by? Nak bagi berapa?
16.
16. Itu cara dia. Senang je, ulang-ulang je. So 1814 bagi 16 berapa?
113.
Sekejap. 113 ada balance tak?
Ada.
Ada.
Berapa?
375.
6.
6 ke? Are you sure? Bukan 15 eh? Satu tiga 6.
6.
6. 113 bagi 16
7.
7. Balance? Ada balance tak?
4.
1.
1. Sorry.
1 Okay. 7 bagi 8 kosong. Betul ke ni macam salah je? Salah ni. 113 kali 16 berapa?
1808.
Oi. Mesti ada salah dekat sini. Sekejap
Betul.
Ya.
Macam mana F tu boleh jadi 6?
Itulah pasalnya. Patutnya 15 ni. Cuba kira kat sini. Macam ada salah je. 16 kuasa 2 kali 7 berapa? 16 kuasa 2 kali 7.
1792.
Betul. 1 kali 16.
Yang last kali kot saya. F tu macam mana boleh jadi 6?
Ni. 16 kuasa. Oh. Astaghfirullahalazim. Sorry. F lah. F kali 16 kuasa 1. F ni nilai dia berapa?
15.
Nilai bukan kedudukan Harap faham beza nilai dan kedudukan. Sekejap, kita stop sekejap. We stop here. I want to repeat the value of F. I just want you to particular not confused with the value. Okay, this one So 15. Okay, F here, the value of F is 16 So A 10, B 11, C 12, D 13, E 14, F 15. That is the value, but the sequence in the sequence of number, 15 is come after 14. So this is the location of 15, the real 15. So this one is the real 15. So do not confuse the real 15 here with the real the 15, the value of 15 carried by F. Jangan confuse Boleh tak yang tu dulu? Faham tak?
Boleh.
Faham tak?
Faham.
Sebab nak kira senang kan? Kalau kita tak tahu nilai F berapa, nak tambah macam mana? Kan? Tak tahu kan? F tambah 1, 10. Kalau F tambah F, dah tak tahu kan? Jadi, di sini, we get back to the previous question. So, here is 15 lah. 15, so this one is 15. Tambah balik. 1792, 16 campur 15. Berapa?
1823.
1823 bagi 16.
113.
Balance 15, betul?
15.
Baru betul. See? Awak tengok macam mana kita boleh semak jawapan kita sendiri kan? So in my class you can check your own answer, that if there's a wrong that makes the things that make you confused, there must be something wrong in your step. So check balik, kita dapat for sure we will find out the point where our calculation is wrong. So 113 bagi 16 divide by 16.
7.
7. Balance 2. Betul tak?
Balance 1.
Balance 1. Okay, balance 1. 7 bagi 8, kosong, balance 7. Kan dapat balik? We read from left to right and bottom to top, we got 0, 7, 1, 15. 15 mean F so we get back the question. So 0 ni kita boleh ignore. See? We get back the answer. We get back the question here, 71F. See? So that's why in my class you can recheck your own answer, you know. There is a technique how to recheck your answer. So at this stage we have learned the relationship between hexa and binary, and then how to convert binary to hexa lah, as well as hexa to decimal, hexa to decimal. So dah ada banyak teknik dah ni so I highlight this part with okay, with this color. See, this one is for hexa to binary and binary hexa to decimal. The grey one is for octal and binary and decimal, and this one I use one color lah. So binary to decimal, decimal to binary. One color kita guna green lah. Alright. Dah selesai. Senang ke susah?
Confused sikit doktor.
Ya.
Yang soalan last tadi tu kan, kalau kita dapat soalan tu terus 1823 base 10 bukan ke hexadecimal kan. Macam mana kita nak tahu yang 15 hujung tu F atau 15 tu hexadecimal punya number?
Kita akan dapat 15 ni macam ni macam mana kita nak tahu itu adalah 15 value atau 15 F 15 F ataupun 15 itulah susunan itulah okay, sebab exactly 15 ni dia mesti 15 carried by digit F. Kalau 13 tu carried by C. Kalau 10 carried by A. It is not the real location yang susunan tu lah. Why? Because we divide with 16. 16 dekat sini. 16 dekat sini 16 location ke 16 value?
Location.
16 location sebab ni tak termasuk A sampai F 16 dekat sini yang kita bahagi dengan 16 ni. 16 ni value. Dia tak termasuk A dengan F. Sebab apa? Sebab kalau termasuk A dengan F, susah Sebab yang kita bahagi ni, yang kita bahagi tadi, yang awak bahagi 1823 bahagi dengan 16 tadi, you divide 1823 with 16, that 16 do not include A to F. 16 tu dalam decimal, betul atau tidak? Sebab kalau 16 ni termasuk A sampai F, awak takkan dapat 113. Sebab awak kena bahagi lebih daripada 16 yang biasa, betul tak? Awak kena bagi dengan 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 10, 11, 12, 13, 14, 15, 16. Sebanyak itu awak kena bahagi. Betul tak?
Betul.
So dia lagi banyak. So 16 dekat sini dia tak termasuk A sampai F. It is not include A to F. This is the real 16 dalam decimal. Sebab keupayaan kita membahagi dalam decimal. So this number 16 is decimal. So that is why 15 dekat sini, 15 decimal lah, 15 the carry. Maksudnya 15 yang kedudukan dia kedudukan 15 sebenar. Which is mana tadi? Mana sequence tadi? 15 sebenar dekat sini lah. 15 sebenar. Dekat F ni 15 sebenar. Kalau the real 15 is carried by F. But the 15 for hexadecimal is here. It's different, different. I repeat, this one, the highlight 15 is 15 for hexadecimal, but the real 15 is carried by F. Carried by F. So, here we divide with 16. 16 here does not include A to F. It is a 16 decimal. Okay, that's why we got 15 here. So, 15 here means F lah. F. If you guys think that this is the 15 in hexadecimal, so this 16 is not the normal 16. because it contains A to F. So susah sikit nak bahagi, dia jadi banyak Dia jadi banyak. Clear ya?
Ya.
Okay, clear. So whatever digit. Oh, one more things. Tepi ni digit This one is digit. Digit means that 15 ni combination of digit. So normally balance is in digit, not a combination of digit. Why? Because this balance will not exceed this one. Awak kalau bahagi satu, of course lah, kalau contoh macam 3 bahagi 2, dia ada balance 1. Balance tu takkan melebihi 2, sebab kalau melebihi 2, awak still lagi boleh bahagi, betul tak? Let's say, saya bagi contoh kalau awak 5 bahagi dengan 2, 5 bahagi 2 awak dapat 2. Kan, 5 bahagi 2 dapat 2, balance 1, betul tak? Awak takkan dapat balance 3. Sekejap, saya tulis sikit Mathematics is fun, you know. Dia ada limit sebenarnya. Tengok Saya buat contoh dekat sini. Ini contoh kata ni saja nak main-main nombor. We just want to play around with numbers Saya harap you all tak tidur lah dekat sana hujan-hujan ni kan. Okay, katakan kita ada 2. Bahagi 2 paling mudah. 5 bahagi 2. 5 divided by 2, we got 2 kan. Balance 1. Ini kita padam, ni kita padam. Okay. 5 divided by 2, we got 2, balance 1 Boleh tak nilai balance ni melebihi 2? Logically.
Tak.
Kenapa tak boleh? Let's say kalau dia lebih daripada 2 ataupun 2, apa yang berlaku sebenarnya? Apa yang boleh dibuat kalau ada balance tu 2? 2 and more lah. Kalau balance ni ada 2 atau lebih daripada 2, nombor tu awak boleh bahagi lagi. 2 bahagi 2, awak dapat 1. So sini boleh jadi 3. Sini 3, ni mesti akan jadi 6. Itu konsep nombor. Sini balance kosong. Itu andai kata kalau balance 2 Ni kalau balance 2 Kalau balance 2 kan 2 kali 2 4. 2 times 2 is 4 plus 2 is 6. So here will become 6. Nampak? So sini tak boleh jadi 2, dia akan jadi kosong. Sini 3. Balance tak boleh macam mana cara cakap contohlah kan, awak ada 3 kek, awak nak bagi 2 orang, so seorang akan dapat 1 dan balance 1, betul tak?
Betul.
Kita nombor paling mudah tadi ada kawan kata betul lah tu. Kita ada 3 kek, we have 3 cakes, we want to divide this cake to 2 person. So each will get 1 cake. So the balance of the cake is 1. Okay, let's say we have 4 cakes. 4 cakes, we divide with 2. Each of them will get 2 cakes. So is there any balance?
No.
No. Logik tak? Awak nak bagi kek. Kek tu nombor dia genap. Awak nak bagi dengan 2, ada balance. Logik tak?
Tak.
Tak logik kan? Sama juga kalau kita ada 3 dekat sini. Bahagi 3. 5 kek nak bahagi 3, seorang akan dapat 1 kan? Balance 2, betul tak?
Betul.
So logically, boleh tak balance ni melebihi daripada orang yang awak nak bahagi? Logik.
Tak boleh.
Tak boleh. Sebab kalau balance ni sama banyak dengan orang yang awak nak bahagi, maknanya boleh bahagi ke tak boleh?
Boleh.
Boleh bahagi. You have 3 cakes balance, you want to divide it to 3%. So still can be divide. Seorang akan dapat 1. Kalau ada 2 kek nak bagi pada 3 orang, baru tak boleh. Dia jadi balance lah, maksudnya jadi balance, jadi point kan. Seorang dapat kurang daripada 1. Itu konsep mathematics. So balance cannot exceed pembahagi dekat sini. Tak boleh exceed pembahagi. So dalam kes yang tadi, balance ni 15. Sini 16. So dia tak boleh exceed. Dia tak boleh exceed so tak cukup. Tak cukup So sekarang 16 dekat sini adalah 16 jumlah digit. Dia mewakili jumlah digit dalam hexadesimal. Sama juga macam ni tadi. Ini jumlah digit dalam oktal ada 8, 0 hingga 7 Kita bagi setiap digit tu seorang satu. Ada 8 digits, right? We divide 462 to 8 digits in octal. So balance is 6. Yang ni tadi kita divide 1823 dalam 16 digit. Why 16? Because we use hexadecimal. So 16 digit is a number of digit, not the value of 16. That is why this one is digit. Dia takkan lebih 15, dia takkan lebih 16 lah, 15 sampai F. Dia takkan lebih sini Nak bahagi kena bagi banyak ni je, bagi 16. Kalau awak kata 16 tadi adalah 16 yang ini, dah susah. Katakan ini masuk 16 Andai kata, let's say this is the value of 16 and it is similar that we use here. Here 16. So it's wrong. The concept is wrong. Because 16 here is not the sequence number after 15. But 16 here is the number of digit in hexadecimal. Faham tak?
Faham?
Saya ulang balik 16 dekat sini bukanlah 16, nombor 16 selepas 15. No. 16 here means 16 digits that we have in hexadecimal. So itu maksud 16 dekat sini. So that's why 15 dekat sini bermaksud digit yang ke-15 lah, maksudnya 15 lah F F. Macam mana saya nak explain? Saya harap faham lah kot Kata mudahnya in the simplified simple word, all the balance here represent digit, not number. So this is the digit 7, of course number 7. This is digit 1, of course number 1. But this one is digit F. F not number, digit. It is a digit, so F lah. Clear tak? Boleh tak? Faham tak?
Faham.
Belit-belit saya cakap but never mind. The point is, if you see this, means this one is F. If it is 13 is C lah. Kalau 14 D. Selesai. Okay, any other question? Okay, kalau tak ada, okay, let's see, I have one question. Saya yang ada soalan Okay, how to convert apa nombor tadi ni? 716 asas 8 into hexadecimal. Apa you nak buat? Tell me how to do it. I will write it for you. Cara ada banyak. Not only one way. We have several methods. At least 2 methods. Or 3 methods that you can use. So what is the method that cross into your mind at this moment?
Doctor, convert to decimal first.
Convert to decimal first. Well, let's do it together. So convert to decimal, we use what technique? Division or multiplication?
Multiplication.
Okay, multiplication. So 7 times with
16.
8.
8.
Eight.
Allah.
8 and power of 2. Okay, 8 and power of 2, correct. And then 1 times 8 power
1.
1. And then
6
6,
times of 8, 0.
8 and power of 0.
Power of 0.
Okay, settle. Berapa kita dapat dekat sini? 8 kali 8, 64. 64 kali 7, 64 kali 7.
Dapat.
448.
448. 448 plus and plus 6 kan?
6.
Berapa jawapan dia?
462.
462. Base apa ni?
10.
10. Ini cara untuk convert ke decimal ya. So base 10 lah. Okay, next. Okay, this is the first step. Ingat je kita nak convert nombor ni kepada hexadecimal Ni one of the technique that you can use lah. Ada banyak teknik lain lagi sebenarnya Okay. So what is the next step? Dah dapat dah decimal ni. Buat apa lepas ni? Apa option yang ada? Apa option yang ada? Tak sampai sah. Yeah. Option that we have. What is the option that we have here?
Bahagi 16.
Bahagi 16 untuk dapatkan apa ni? Nombor dalam
Base 16.
base 16. Andai katalah saya nak bahagi 2 dulu, boleh tak? 62 ni saya nak bahagi 2 dulu, boleh tak?
Boleh.
Kalau bagi 2, saya dapat nombor dalam sistem apa?
Binary.
Binary. Okay, let's see. Okay, saya lupakan ni sekejap tunggu sekejap ini tadi bahagi dengan 16 kan, kita stop sekejap. Okay, let's see kalau 462 saya bahagi 2, I divide 462 with 2, so I got number in binary. So what is the next step to get hexa? Daripada binary kepada hexa, apa dia punya formula?
4 bits number.
4 bit digit equal to mana tadi binary kepada binary kepada hexa. 4 bit equal to how many digit in hexa? 4 bit equal to
Binary digit equal 1 digit hexa.
1 digit. So dapatlah hexa. Okay, that's the first option that we have. Means that from 462 we divide by 2 because we want to get the binary number, or this technique to divide by 2 to get binary. So from binary we change the number using this technique sama je pun boleh, but now we are not going to use that technique. We directly divide this number 462 with 16. Boleh juga, dapat juga hexadecimal, tak ada masalah pun. 462 bahagi 16 dapat berapa? 462 bahagi 16 dapat berapa?
28.
28. Ada balance tak?
Ada.
Berapa? Berapa?
14.
14. Dalam soalan 14 ni dia mesti D. Mesti D sebab dia hexadecimal
28.
Apa 28? 28 bagi 16 1. Balance
12.
12. Banyak balance ni. C. And then apa saya buat ni? 28 bagi 6. Okay, ni kosong So balance kosong. Betul tak jawapan dia? 462 bagi 16 28, balance 14. Betul? 28 bagi 16 1, balance 12. 1 bagi 16 tak boleh, kosong kosong. So sini 16. Sini berapa? 1 kali 16 belen 12, 1 bagi 16. Confuse saya. Berapa belen kat situ? Macam ni. 12, 28 kali 16, 14, 2, 1 kali 16. Kenapa 12 pula? Sini ada 16 ni. 28 bagi 16 berapa? Ulang buat balik. 462 bagi 16.
28.
28 betul lah. Belen? Okay, correct. And then 38 divided by 16? 1. Okay. Belen?
12.
12. 1 bagi 16? 16. Kan? Belen 16 kan?
Belen 1.
Belen 1 lah. Astaghfirullahalazim. Okay. Confused. So the answer is, tengok saya pun dah jadi kebingungan. Okay. The answer is 1, tak apa, never mind. Nanti kita check. 1, C, D kan? Tak ada masalah. Confused ke apa ke, tak ada masalah pun. Okay, let's say lah kita kata ni jawapan dia. Okay, never mind. So this is the question and this is the answer. Ini teknik yang, one of the technique that you can use lah. Okay, let's say saya nak guna teknik yang lain, teknik yang lagi mudah daripada ni. Yang tak melibatkan pengiraan yang susah, yang kira-mengira macam ni lah. So teknik apa yang saya boleh guna? Katakan ni soalan dia. Saya nak buat apa dulu? Agak-agak awak apa saya nak buat ni?
Convert to binary.
Yes, convert to binary. 1 digit berapa bit?
4.
3.
3 dulu, sabar.
Tiga.
Kata 4 tu sabar dulu. Tak sampai lagi. Okay, 3. So macam mana? What's the 3 digits of 7? 3 bit of 7.
1, 1, 1.
Okay, 1.
Then 0, 0, 1.
6.
1, 1, 0.
Okay, selesai. Okay, we have this sequence of bit. Ini dalam binary. What is the next step? Now we have binary number. Binary tu apa yang nak buat lepas ni? Binary dah ada dah ni. Nak dapat jawapan dalam hexa. What's the next step? Kalau saya nak tukar kepada decimal dulu boleh tak? Binary kepada decimal. Boleh tak? Untuk dapatkan hexa?
Boleh.
Boleh. Binary kepada decimal kepada hexa pun boleh. Kalau saya tak nak tukar kepada decimal, saya boleh tukar kepada apa? Untuk lagi cepat.
Hexadecimal.
Apa dia punya formula? Apa formula dia? Dia kata terus tukar pada hexadecimal tadi. So apa formula dia? Binary to hexa. Come on, binary to hexa. Baik tadi banyak. Tu dah ada dah binary to hexa. Apa formula dia?
1 digit hexa
1 digit hexa.
dengan 4 binary digit.
Pandai pun. So ni nak divide 4 by 4 ni from right to or left?
From right.
From right. So from right 4. Saya buat jauh-jauh 4. Ambil. 0 1 ni kita biarkan dulu Okay. 1 1 1 0. What is 1 1 0? 8 9 10 11 12 13. Ni berapa ni? 1 1 1 0. F
15.
F 1 1 1 1 15.
14. 14 E.
E kan? Dapat 8 14. Macam ada something wrong. Yang ni?
13 D.
13 ke 12?
12 C.
C. Okay, this one ada satu je kan, tak cukup 4. Tambah je 0,0,0,0. Cukupkan dia 4. Kita akan dapat 1. Dan kenapa kita dapat 1 CE? Dalam teknik tadi 1 CD. Persoalan yang mana tepat? Awak yakin yang bawah ke yang atas?
Bawah.
Kalau yakin yang bawah, mari kita betulkan yang atas. Dekat mana silapnya? Dalam exam, awak cara menjawab macam ni lah. Kadang-kadang awak semak kan. Kalau semak jawapan awak salah, bukannya there is something, ada step yang tertinggal lah kot macam tu. Dia bukan salah yang totally salah mari kita semak. Ni tadi 716, 71456, 333, 001, 110 Lepas tu 110, 110. Okey, yang ni rasanya dah betul dah. Kenapa yang ni jadi 1 CD? Okey, buat balik 716, 716, 88, 64. 64 kali 7 berapa? 64 kali 7.
448.
Okey, dah betul dah. Yang ni 8, yang ni 6. Okey, 448 campur 8 campur 6. 462 dah betul. 462 bagi 16. Mesti disilap dekat sini. 462 bagi 16 berapa?
28.
28. Dapat berapa? 28 kali 16?
448.
448. 448. 462 tolak 448?
14.
14 A, B, C.
Sir, 14 tu bukan E ke?
10, 11, 12, 13, 14. A, B, C, D, E.
Bukan
E.
15.
Ya, see? Dapatlah 1 CE. Yes. See? See? So sekarang, apa yang berlaku sebentar tadi adalah kita sedang menyimak jawapan. So dalam exam, in the exam, you need to very efficient. Let's say kalau awak dah buat teknik ni, katakan let's say you do this technique, okay, jangan confident terus betul tau. Awak check balik guna salah satu teknik option yang ada. So macam ni option yang ada, bila kita check, oh silap dekat tepi ni. Silap baca je, bukan silap apa pun so that is why we need a lot of technique for one question. Just because to semak jawapan kita Jadi semak jawapan tu sebenarnya is a comparison process. We compare the process. Semaklah compare kan. Compare between two process, either it is which one is correct and which one is wrong. So apa yang awak buat tu comparison tu is actually is a kebat lah. Kebat level 3 atau level 4 saya tak ingat. Dia membezakan, differentiate. So baguslah kalau awak boleh buat comparison. Kalau awak terus menjawab, let's say kan, yang bagi soalan tadi kan, saya bagi soalan ni convert kepada hexa. I give you this question and you convert to hexa, and let's say you just directly write this technique kan. Okay, this is application tau. Application level, you apply the technique. First one, I teach you the technique and then you remember and then you apply. Apply tu level 3. Application kan. Let's say you compare the answer with another technique, yang ni dah level 4. Level 4 ni cognitive skill awak makin meningkat lah. Kalau awak boleh create another question, you check on your own, tu dah level 5-6 5-6, you can do on your own. Tu level 6 lah tu. So ni level 4. Kalau level 5 tak silap saya, analysis dia punya verbs dia saya tak ingat apa analysis tu mungkin awak tak sure, comparison analysis. Mungkin awak boleh define kot dia punya ciri-ciri, I'm not sure. Awak boleh refer pada taxonomy belum So apa yang kita buat ni, comparison ini level 4 level 4 we compare the technique, and then we look at the difference or distinction between both, and then at the same time we can check our answer. Gitu. Teknik ada banyak macam saya sebut tadi. Okay, the first technique here, your friend change octal to decimal and decimal to hexa. For this one, from octal to binary and binary to hexa. You can also from octal change to binary, from binary to decimal, from decimal to hexa. Boleh juga. Or maybe from octal to binary, binary to hexa. Macam ni tadilah. Boleh juga. It's a lot of technique lah. Maksudnya at least ada two techniques lah. Two techniques to change from one system to another. Dia takkan lebih daripada, dia takkan ada 15 cara dia just ke depan, forward, backward. Macam tu je. Okay. So inilah sistem nombor. So until today, we have learned about numbers. Okay. Which is we have, awak conclude lah, cuba buat kesimpulan sikit. Lepas ni kita nak rehat sekejap. Kemudian kita sambung dengan nombor perpuluhan. Nombor perpuluhan is the last number, is the last topic in arithmetic dan habis dah. Tambah, lepas tu nombor perpuluhan. Nombor perpuluhan, lepas tu operasi tambah lah. Lepas tu habis dah, tu saja. So sebelum kita berhenti rehat sekejap, okay, can you make a conclusion what you have learned from last week until today? Apa yang awak dapat daripada kelas saya ni? First of all, apa yang awak dapat daripada last week sampai hari ni? Bagi satu ayat pun tak, bagi satu point pun tak apa. Apa yang awak tahu? What do you get from my class from last week until today? Okay, apa benda asas yang awak perlu tahu? What's the foundation or the basic things that you need to know in my class? Mula-mula sekali. At the beginning.
Dr. Number system. We learn 4 different number system.
Okay, kita ada 4 number system. We learn 4 different number system. Who can name it? And tell us what is the digit that exists in each system.
We have binary, octal, hexa, and decimal. Decimal is 10 digit, octal is 8 digit, hexa is 16 digit, and then binary is 2 digit.
Okay, good. So what is the justification why I teach you binary? We learn about binary. Why?
Because machine language is based on binary.
Okay, good. And what about decimal? Why do we learn that? Kenapa kita belajar nombor desimal?
Because decimal is used in everyday life.
Yes. Nombor 10, decimal is very important because that's the number that we always use in daily life. So our reference is decimal. That is the point why we learn about decimal. Okay, and then why do we learn about octal and hexadecimal? Nobody can answer me. Saya ada ulang, I have repeat some of the like 5 times. Why did we learn about octal and hexadecimal? Apa sebab dia? ada beberapa kali saya dah beritahu lah why. Apa sebenarnya ialah saya saja mengajar sebab apa yang saya cuba buat sebenarnya, what actually my objective towards you. Saya nak bagi awak satu apa sebenarnya bila saya mengajar tentang octal dengan hexadecimal.
To be converted from binary.
Selain daripada tu, more to more simple word. Tadi your friend told us that we learn about binary because machines speak in binary language. Decimal because the number that we use in our routine daily life is in decimal. And how about octal and hexa? Tak payah fikir jauh-jauh, it's very simple things je. Very simple things. Kenapa?
Because very easy to convert to binary.
Okay, never mind. I told you very easy to convert to binary. Dia macam ni, I teach you about octal and hexadecimal because I want you guys to think out of the box. Okay, out of the box. Okay, kita belajar mathematics bukan you nak guna all those formula in your work. Let's say you want to be let's say one day awak bekerja sebagai, you will get the environment kerja sebagai engineer. Bila masa awak nak guna formula all of the mathematics formula kan? So it's not directly, literally used in your work, okay? But the cerita, the story behind is I want you think out of the box. Box means in your routine you learn to calculate in decimal. The decimal has only 10 digits. So for octal system, I just want you to think out of the box. What would happen if you only have 8 digits in your life? Macam mana kalau dalam dunia awak hanya ada 8 digit? How do you calculate? How do you do arithmetic? Same goes to hexa. The reason why we learn about hexa is to make you think out of the box. What would happen if in your life you have digit more than 10? More than 10 digits. So how to calculate? Itu je. Itu sahaja sebenarnya. It can be 16, it can be hexa, it can be penta, it can be octal, it can be penta or 7 digit or 6 digit or 5 digits or 4 digits. Any digits. Okay, it can be any digit. So in this class, we pick octal and we pick hexa just to represent what should we do or how we can calculate or manipulate the number if we have less than 10 digits and one more number system is more than 10 digits. Tu je. Kan? Let's say a question asks you to calculate an octal. So you need to dismiss all the numbers that combine 8 and 9. So you put yourself in a new world without 8 and 9. So how do you calculate? Let's say you have a clock without 8 and 9. So what would happen? Macam itulah. Kalau hexa is we have more digits than usual. So what will happen if our watch have 16 digits? So the purpose why we learn about this is we just want you to think out of the box. Tu je. And then for today, for this week, we just want to relate each of this number just because to make sure that the number that we use is correct. So how do we know that the numbers that we use are correct? So we need to base everything that we do, we need to refer to base 10 lah, base 10. Because our daily routine is based on 10 decimal. So we learn today how to relate 16 to decimal octal to decimal, binary to decimal, and vice versa. Okay, now, let's say, okay, I'll give you one question. Let's say this year, your birthday is 21 years old. Of course, 21 is in decimal. So what is your age in hexadecimal? Maksudnya think out of the box. In your life, you live in another planet. There is no, the number is more, the digits exist is more than 10. So what is your number in that planet? Your age in that planet? Nak buat macam mana? So you need to use the techniques lah to relate decimal to binary, binary to hexa, or directly decimal to hexa. And then you check your answer using another technique just to make sure that your answer is correct or wrong. Okay, this one is the last question before you take a break for 5 or 10 minutes. Okay, katakan umur awak 21 tahun. Let's say your age is 21. So please get your age in binary, in octal, and then in hexa. Cuba buat. Nak guna teknik apa? We do step by step. Okay, mula-mula nak buat apa?
Divide by 16.
Nak cari octal dulu.
Oh,
Divide by?
divide by 8.
Okay, divide by 8. Okay, 21 bahagi dengan 8 berapa? 21 bagi 8.
2 bagi 5.
2 bagi 5. And then 2 bagi 8.
Kosong.
Bagi
2.
2. So kita dapat. So dalam umur awak adalah, dalam oktal umur adalah
25.
25. Okay, secara random betul tak 25? Sebab kita tak ada nombor 8, kita tak ada nombor 9, kita tak ada nombor 18, kita tak ada nombor 19. So kita kena tambah 4 lagi kan?
Betul.
Kita tak ada 8, saya ulang balik kita tak ada 8, kita tak ada 9, kita tak ada 18, kita tak ada 19. So 9 kita miss. Kita skip this number. No 8, no 9, no 18, no 16. So 4 numbers. So daripada asal 21 campur 4, 25 kan? So kita dapat 25, nampak? It's a mathematic formula. Dia macam mathematic patterns. Okay, ini kalau kita buang 2 digit, maksudnya miss out 8 and 9 lah. Okay, let's say dalam hexa pula. Dalam hexa, apa teknik yang ada? 21 bahagi
Divide by 16.
19.
divide by 16. So we got
1.
1 balance.
5.
Balance 5 juga. Okay, kemudian 1 bahagi 16. Kosong. Balance
1.
1. So in hexadecimal, your age is
15.
15. Jadi makin sikit. Sebab apa? Sebab kita nombor jadi makin panjang. Okey. Kalau tak percaya, cuba 15. Okey, kita ada A, B, C, D, E, A, B, C, D, E, F. Tambah 6 kan? Cuba 15 tambah 6. 15 16, 17, 18, 19, 20, 21. Kita akan dapat 21. Sebab nombor kita jadi lagi panjang. So kita punya umur ni termasuk dia jadi 15 ni sebab dia ada A sampai F. Lepas 9 dia bukan 10. After 9 is A. A, B, C, D, E, F. We need to add 6 more digit to get 10. Before 10 we need to add 6 more digit. And then we got 10. So that's why after 9 we have A, B, C, D, E, F. And then 10, 11, 12, 13, 14, 15. So that's why kita jadi makin nombor tu makin lambat bergerak makin lambat bergerak. So now if in octal we got 25, in hexa we got 16. So it means 25 is equal to 16 logically. So let's check, is it correct or wrong? Ini nombor mudah, senang lah kita nak check. Tadi pun dah tengok dah logik dia ya. Tambah berapa tolak berapa. So logik tak kalau 25 asas 8, 25 base A equal to 15 base 16. Is it logic or not? Apa kita nak buat ni kalau kita nak buktikan ni? Prove it. Okay, macam mana nak how to prove this both number is equal? Agak awak nak guna teknik apa?
Tukar dua-dua kepada
Maaf, suara awak hilang. Tukar kedua-dua kepada
binary both.
binary. Pandai. Ini paling mudah sekali. Okay, 25 tukar kepada binary. Jadi apa? Jadi apa? 25? Guys?
101.
101 3 dek. 2 berapa?
10.
10. Satu biji berapa bit? Untuk total? 3. So kita tambah apa lagi?
0. 0, 1, 0.
Pandai. 5?
101.
101. Ni kenapa bertitik ni? 101. Okay, another one. Yang ni pula.
0, 1, 0, 0, 1.
Okay, 5. 5 adalah
0010.
0010 is 2. 0
10.
010
1.
1.
Yes. So sama tak dua-dua ni? Mari kita gabungkan yang ini. Dengan yang ni. Kalau sama dengan yang ni. Okay. Kosong dekat depan kita boleh ignore tak ada masalah. Dia tak carry apa-apa. It has no value So kita buang ni, kita buang lah kita ignore ni. And then we ignore all zero here. Okay, sama tak? Jawapan dia. Sama. Betul sama Guys, sama tak? Sama. So maknanya 21 asas 10. If you use this technique, dapat 25. If you use this technique, dapat 15. So adakah kedua-dua ni sama? Kita dah buktikan bila tukar dengan binary, kedua-dua ni adalah sama. So kesimpulan kita boleh buat adalah teknik ni betul. Teknik bagi 8 ni betul. Teknik bagi 16 ni pun betul. Sebab jawapan yang diperolehi ini nilainya sama. Macam mana tahu sama? Kita guna basic foundation binary. Selesai. So di sini sebenarnya saya nak ajar awak tentang logik lah. So apa-apa yang awak buat, awak boleh semak dan awak boleh buktikan jawapan awak betul. Nak bukti macam mana? Sama ada guna foundation binary system, iaitu binary ataupun decimal, antara dua je. Sebab biasanya binary lah yang kita guna untuk buktikan jawapan kita tu betul. Decimal pun boleh juga, tak ada masalah. So itulah apa yang kita dah belajar sepanjang-panjang ni. Apa sampai hari ni is all about apa nama ni lah, logik dan pembuktian. Teknik tak susah pun, bahagi 8, bahagi 16, bahagi 2 ataupun darab dengan asas 2, asas 8, asas 16. Kemudian untuk okta dengan hexadecimal, kalau ke binary just bahagikan 333 atau 444. Itu saja. So tak banyak pun kalau awak buat mind map, teknik yang digunakan tak banyak pun. So tak perlu serabut. Don't mess up your mind. So the technique that use is very only a small number of formula that we or technique that we use. Not so many techniques. So don't mess up your mind. Okay. So kita stop sekejap about 5 minutes. Afterward, I will teach you about floating point, nombor perpuluhan. Nombor perpuluhan is last number lah yang kita belajar. Maksudnya kita ada nombor bulat, kita ada nombor perpuluhan. Nombor pecahan is nombor bulat, nombor perpuluhan lah, nombor pecahan. So kita berehat sekejap 5 minit. Okay, hello. Anybody home?
Yes, sir.
Yang lain ada?
Yes, sir.
Lagi yang lain?
Hello, sir.
Hai. 3 lagi. Nur Eliza ada?
Ada.
Primela? Primela
Ada.
Pasda. Okay,
Ada,
good.
ada.
So cukup 5 orang je lah Just nak make sure that you are there. So taklah ada I bercakap seorang-seorang So the number that we have learned setakat ni adalah nombor bulat So what if we have fixed number fixed point? Fixed point adalah nombor perpuluhan yang kecil So bukan nombor perpuluhan yang jenis yang panjang-panjang tu. Because it's different it's different between that both perpuluhan So let's say we have 5.25 Let's say we have this number 5.25 So the first step where if you want to change or convert this number into, of course, decimal lah, binary binary. First of all we need to change 5 ni dulu, change 5 into binary lah. 5 into binary, then mula-mula 5 base 10 binary, then the second step 0.05 into binary Okay, this is the first step. The second step is 0.05. Okay. Dulu 5 kepada binary. So ni nak guna teknik apa? Bahagi ke darab? Decimal kepada binary. Decimal to binary. Guys, nak guna teknik apa ni?
Bahagi.
Bahagi berapa? Bahagi dengan? Bahagi berapa guys?
2.
2. So 5 bahagi 2 berapa?
2.
2 balik baki?
1.
2 bagi 2? 2 bagi 2?
1.
Balance?
0.
0. Jadi 5 bersamaan dengan 5 equal to
101.
Okay. So dapat dah 101 base 2. Ini biasalah teknik yang kita gunakan And then 0.05. 0.05. Ini persamaan Okay. 0.25 kita guna kaedah. Okay, kalau lah nombor, let's say the number before after the point we use division. So the number before we use what technique? Kalau 5 kita guna bahagi 2. Kalau 0.25 nak guna teknik apa? 5 we use divide by 2. 0.25 bahagi lawannya opponent for division is
Darab.
darab. Jadi 0.25 darab berapa agak-agak? Agak-agak je. Darab
2.
2 pandai. Dapat berapa? 0.25 times 2?
0.5.
Betul lah.
0.5.
0.5. Okay, 0.5 ni kita ambil balance adalah yang di depan ya. Ni adalah balance. The red one is balance. So balance is 0. Kita ambil ni bawa belakang. This. Okay. Okay, next. Kemudian yang biru ni, color this, I put the color is blue. So kita ambil blue bawa pergi depan. So ada 0.5 lah. 0.5 kan? 0.5 times 2. Darab 2 juga. Sebab nak tukar pada binary. So kita dapat 0.5 kali 2 dapat 1.0. 1.0. So balance dia berapa dekat sini? Kalau guna cara yang atas ni tadi, yang ni berapa balance dia? 1. Yes. 1 So kita ambil yang 1 dekat depan ni. Kita jadikan dia balance lah. Okay. And then yang belakang ni 0 kan? So 0 ni 0 tak ada apa-apa lah. 0 times 2 is 0 Dapat 0 lah. 0. Tak pakailah Okay. So 0.25 is, kalau ni tadi read from top to bottom So there's one this time wait. This one is from bottom to top. So this one is from top to bottom This one from top to bottom. Macam tu So this way, how we read it this way So the representation of 2.25 in binary is dapat 0.01 Yang ni 0 and 1 balance dia, ada balance dia You read the balance 0, 1 So 0.01 So if you combine both, so 5.25 is equal to, susun je balik nombor tu. 5 tadi berapa? 101.01. That's it. Dah siap. So teknik ni je yang kita tambah petang ni. Teknik ni, dia lain sikit daripada tadi. I put it in orange color. So ini untuk floating point. Okay, of course kita boleh semak jawapan kita, tak ada masalah. Nak semak macam mana? Biasalah daripada decimal. Daripada binary. We check our answer. We check. So from binary, kita convert balik kepada decimal. Kita guna kaedah. Dua-dua kena guna sebab satu nombor sebelum perpuluhan, satu lagi selepas Jadi 101 ni asas 5, asas 10, asas 2 is equal to 1. Kalau binary kepada decimal kita guna kaedah darab 1 kali 2 kuasa 2 tambah 0 kali 2 kuasa 2 tambah 1 kali 2 kuasa 0. Patutnya dapat 5 lah Okay. Untuk yang point tu, kalau nak teruskan pun boleh juga titik kat sini. Okay, 0 kali berapa agak-agak? Kalau ikut jadual kan, yang ni 2 kali 0 is 1. 2 kali 0 is 1. ini 2 kali 1 is 2. Lepas tu 4, 8, 16, 32, 64, 18. That is the sequence lah. 0, 1, 2, 4, 8, 16, 32, 64 kan. So, but for the number before point, we need to time it with 1 over 2 kuasa 1. 1 per 2 kuasa 1. 2 kuasa 1 adalah 2. So 1 bahagi 2 adalah 0.5. 0.5 Atau inilah 2 kuasa negatif 1. 2 kuasa negatif 1 ni bersamaan dengan 1 per 2 In mathematics is equal to 1 over 2. Tambah dengan 1 kali 2 kuasa berapa? Ini 2 kuasa 1, ini 2 kuasa 2. 2 kuasa 2 adalah 4 Macam tu. So in point form kita akan dapat macam ni. Kita akan dapat 1 kali 4. Just want to make you clear how we get the sequence for the number before point form. 0 kali 2 tambah 1 kali 1. Macam tu. So kita dapat the sequence is 1, 2, 4, 8 and so on lah. So for point here, kat sini kita ada 0 kali 2 kuasa negatif 1 adalah berapa? 0.5.
0.5.
Pandai. 0.5. Okay. Kemudian 1 over 2 and the power of negative 2. Okay, ni 1 kali 0. Berapa? 2 kuasa negatif 2 berapa?
0.25.
0.25. Macam tu lah dan seterusnya. Jadi, okay, for this sequence of number, I just expand it from here ya. So we do together supaya awak tak perlu guna calculator lagi dah. Ini untuk nombor-nombor sebelum titik perpuluhan. So I copy this table, I put it down here. This is the number after titik perpuluhan So sini kita dapat 0.5. This is 2 kuasa 1, negatif 1. Kemudian sini tadi 0.25 kan? 2 kuasa negatif 2. Sekali lagi. Ini untuk nombor-nombor sequence after before the point Kemudian 2 kuasa negatif 3 berapa?
0.125.
0.125 and then 2 kuasa negatif 4.
0.0625.
Bisa 625. The last one, to the power of negative 5.
Sir, 0.0625.
0.0625 and then lagi 0.0.
0.03125.
Okay, cukup. So you just need to know only from to that extent tu je. So ni nombor-nombor selepas titik perpuluhan, sebelum titik perpuluhan. Copy balik, I paste dekat sini. Kenapa? 1, 2, 3, 4, 5. So ini titik perpuluhan So I put dot here and dot here. Okay. So hafal lah ni Okay, so tadi kita ada sampai 0.25 Only 0, okay, 0.25 sebab dia 2 titik perpuluhan saja. Okay, so kita teruskan lagi. So yang ni kita dapat 4 campur 0 campur 1 point 0 campur 0.25 macam tu. Macam tu bezakan sikit lah. Sebenarnya kena buat asing ni yang lain-lain tapi saya mana-mana pun boleh lah kita sekalikan. So nak sekali kita kena buat bracket lah macam ni, parenthesis. Okay, so we get this. So boleh selesai lah ni. Okay, dapat tak 5.25?
Dapat.
Okay. 5.25. Okay. Asas 10. Okay, so selesai. So this step is from mana tadi? Okay, this one is from decimal to binary. Okay, this step is to check lah. So kalau nak convert from binary pun to decimal, this is the technique lah. Kena buat asing ni sebenarnya, dia sebenarnya macam ni, dia kena pecah-pecahkan. Yang ni buat dekat atas. Yang ni buat dekat bawah. Macam tu. 1.01 itu 1 macam tu baru betul. Ni baru betul. Boleh buang, boleh buang. Boleh buang, boleh buang. Ini kopi kat bawah. Ni cara yang betul. Tu. 10. Baru cantik So this one tu copy balik. This equal to 5.25 plus 10. Selesai. Okay. Untuk fixed point. So the new things here is this one lah. The number after before titik perpuluhan tu, before point form tu this is the new technique lah for you. This is from decimal to binary, but from binary to decimal, the new techniques is here this one. This new technique lah. New technique because you need to times the number, the bit with 0.2 and power of negative. Barulah ni negatif. But never mind, I already give you the sequence for negative number in this table. Kita buat dia sama-sama. I already give you this value lah. So just remember this. This is for the number after titik perpuluhan, after point form. This is the value before point form. Okay. So dah ada dekat situ. Guna je balik. Just reuse it. So this is for the fixed point. So for the last one today, ada satu lagi nama dia floating point. Fixed point ni pendek. Kalau floating point ni dia ada 32 bit jawapan dia. It's a 32 bits answer. It's quite long. Satu lagi lepas tu habis. Minggu depan kita dah boleh main tambah-tambah, operasi tambah. Next week we will do the additional operation. I just want to finish it up this week because next week is Ramadan. So this one is quite tough to teach. So that's why I want to make it finish today lah. Okay, let's say we have floating point. Tadi fixed point, ni floating point. Okay, floating point ni the number is maybe similar with the first one, but the difference is when the question asks you to represent this number by using represent 5.75 or 25 just now with represent 5.25 with or by 1 I triple E 784. Ni nama dia lah, nama formula dia 784 1280784. So how to represent 5.25 by in I triple E 784. So the technique is like this. Okay, first of all, this is for the big number actually. Okay, katakan, okay, the first technique is similar. We use this technique untuk 5. Untuk 5. This is the last one, don't worry. This is the last one for today. Okay, this one is so far. So we use the same technique. This one. Put it here. Okay. Okay, for 0.25. Okay, kita guna teknik ini sekejap. Sekejap. Sekejap ya. Sekejap. Ini dia ya. Okay, kita guna teknik ni. Yang sama juga. Kita copy yang atas ni tadi. Mana dia? Okay, this one. Soalan dia sama 5.25. The question is similar like previous question, which is 5.25. So we use the similar technique. So we got this lah. Okay. Kita dapat ni. Ini kita dapat ni. So now yang ni. Okay, kat sini this is the starting point where the difference between the fixed point and floating point happens ya. Dekat sini perbezaan dia. Okay, okay, first of all, okay, the first step you need to bring this point form forward. Bring it forward until where? Until it's arrived at before the first one digit. The first digit one, the first digit one. So it means from here to here. Here in the middle here. Here, So we will get it's equal to 1.0101 times 2 and power of 2. Okay. Okay, there are two questions here. Okay, pertama, for the first step, you need to carry this point form to the front until you find the first digit of 1. So what does it mean? It means, let's say the number is like this. 11110000.111. So this number is equal to 1.1100111. It's equal, the value is similar, but we need to time with 2 because it is in base 2, and the power of how many step that you carry forward. 1, 2, 3, 4. You jump 4 times. 1, 2, 3, 4. So 2 and the power of 4. Okay, so this is what I did here. Similar, it's similar. So the first step, you need to bring the point to the front until you find the first one in that sequence lah. So it will become like this: 1.1100111. So it's similar like this one. I bring this one point, so it become 1.0101. But you need to time with 2. 2 is the base 2, and the power of how many you jump. This one 1, 2, 3, 4. So this one is 1, 2. Okay, do you understand at this step? Faham tak setakat ni?
Faham, sir.
Yang lain? Okay. Faham
Faham, sir.
Okay, good. Okay, this is the first step. First step lah. So you just move the point form to the front until you find the first one digit, and you times it with base 2 and the power of how many you jump. Okay. This one is example lah. The star kat sini. Okay. Kemudian the next step. So this is the first one. Then okay, we do this, and then the next part. Okay, you use this formula, exponent. This is the formula, minus 127 is equal to how many you jump. Here, you jump how many times? In this question? Alamak. Lompat berapa kali tadi? 2. So it's equal to 2. Saya ambil color warna yang sama supaya awak tahu dekat mana saya ambil ni. So equal to 2. Blue. So this one is blue. Yellow lah baru nampak. Yellow and yellow. This one is red lah. Okay. So from here, exponent is equal to 2 plus 127. Kita akan dapat 129. 129. So in binary, 129 is 128 plus 1. 128 plus 1, so 1, 2, 3, 4, 5, 6, 7, 8. So this is 129 in binary. Kalau awak dah hafal, awak boleh terus buat. Senang. 1 campur 128. Just look at the table here. Okay, 128 plus 1. 128 plus 1, so we get 129. So how many 0 in the middle? 1, 2, 3, 4, 5, 6 0. So we have 6 0 here. 1, 2, 3, 4, 5, 6. Okay, this is 129. This is the exponent value. Okay, I put color apa? Gray. And then we need to find out the sign. The sign for this question. Sign is standard. Nobody know positive atau negative. If the number is positive like this, 5.25, so the sign is 0. Because the number is positive. But if the number is negative, so sign is 1. Sign this one, sign is 1. And then fraction, you just take it from here, from the green one. After you move the point to the front, you take the digit before the point form. Take the digit before point. So 0101, we just take it. I put this color as apa lagi purple, yellow, orange, blue. So I take this blue, I put it here. Okay. And then I put, sini ada 24 kan? Ada 4 nombor. So fraction ada 23 bit. So 23 minus 4, we got 19, right? 19. So we put 19 kosong. Okay. 1, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 1, 2, sorry. 19, 2, 4, 6, 8, 10, 12, 14, 16, 17, 18, 19. 4, 8, 9, 10, 11, 12, 13, 14, lebih. 4, 6, 11, Ya Allah. 23 bits. Overall 23 bits. It must be 23 bits. So, okay, now we write down the answer. So IEEE, the IEEE format for floating number here is 5.25 base 10 is equal to, okay, first of all, you need to put the sign. The sign here is 0. The format is sign and then exponent and then fraction. This is the format. Sign, exponent, and fraction. Okay, the sign here is this one, 0. SIGN or S. Saya letak warna sini. Okay, so sign is 0. So I take 0 here and I put it here. 0. So this sign. And then I put exponent here, exponent, this is an exponent. Okay, and then fraction. Fraction is this one. So fraction, exponent, and sign. So this is the fraction. And then we have sign. The exponent tadi warna kelabu. This is the exponent. So overall, there must be 32 bits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32 bits. So this is the representation of floating point 5.25. So if you want to check it, of course lah, we want to check our answer. Apa nanti awak study balik. To check the answer, we have 3 formula. Saya copy dekat sini terus formula tu supaya awak boleh study. Copy, we have 3 formula. Tak faham tak apa, don't worry nanti study balik. Ada 3 formula dekat sini. So start formula ni berguna untuk 3 keadaan berbeza. Okay, dalam case yang ni, exponent ni nilai yang di tengah-tengah ni nilai di tengah-tengah. So in this case, the exponent is 1 to 9 1 to 9. Kat sini kita dapat dah 1 to 9 tadi. 1 to 9. So we take this here, kalau exponent antara 1 hingga 2, 5, 4, the syarat is here, the rules is here. So if the exponent is between 1 to 1 to 5, 4, we use this formula. So now our exponent is 1 to 9. 1 to 9, the grey one the grey one is exponent. So we use the first formula to get back the decimal value. So -1 power of s times 1 dot fraction. Fraction here is 0101 blah 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 lah. Okay, 0101 ni nanti kita tukar dalam we change it into decimal times 2 and exponent minus 1 to 7 So this is the formula that we will use to get back the decimal value. So kita tukarlah -1. S here is 0 0. Copy, we put 0 here. Okay, S is 0. And then we times it with 1 dot fraction. Fraction is 0101. Okay, 0101 0101 0101 ni berapa? 0101 we refer to the table up here. Mana tadi? Nombor titik perpuluhan. Yang ni. 0101 0.25 tambah 0.0625 0.25 tambah 0.0625. Nanti kita boleh tuan tambah tak ni? Berapa jawapan dia? Mana? Sorry, ni bukan fraction, fraction yang ni lah. Exponent is 129 tolak 127 129 kita ambil daripada sini, exponent. Satu dua sembilan tolak 127. So kita dapat negatif 1 kuasa kosong adalah 1 kali 1 point. Ni berapa ni? 0.25 tambah 0.625?
0.3125.
0.3125 kali 2 kuasa 129 tolak 127 2 dapat ke tak dapat ni tak tahulah. So 1.3125 darab 2 kuasa 2 adalah 4. Berapa jawapan dia? Apa ni?
5.25.
Alhamdulillah. So 5.25 betul So we get back the decimal value for this yang panjang-panjang ni. Tu saja. Ni untuk recheck lah. Okay. So kesimpulan dia adalah untuk yang floating point, fixed point Okay, fixed point. Okay, mula-mula we get the representation for the number before titik perpuluhan using the similar format that we have learned before this, which is divide by 2. And then we get the representation for number after titik perpuluhan, which is using this technique lah. This one is a new technique lah, different from previous one. Okay, so we got the answer lah. This is the answer if the number is fixed point. Itu yang pertama. Let's say if the question is fixed point. If the question is, okay, this is how to check lah, how to check our answer just now. So we just use the multiplication technique to get the number, the both number lah before and after titik perpuluhan. Cuma beza dia, before titik perpuluhan we times it with 2 and the power of blah 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 blah, and the number after titik perpuluhan we times it with 2 and the power of negative something. If you cannot remember this, I already put it in this table lah. The value for 2 and the power of negative something. This is the value. So we check the answer and then we get back the question lah. So means that our answer is correct. But for floating point, okay, the first step, similar like previous, you just get the representation for the number after and before titik perpuluhan using the technique that we have learned in fixed point. But the next step is you need to move forward, move the titik perpuluhan forward until you find the first one, the first digit, the first one digit, and then put your titik head over there, and then you just time it with 2 because it is in base 2 and the power of how many you jump, how many you jump. So I put how the number of movement, the number of movement. How many steps that you move forward, So 2 is the number of movement, Power of 2. The big 2 represent base. Dua yang besar ni represent base, while power of 2 represent the number of movement. Okay. So and then we use this formula. This is the formula, exponent minus 127 equal to 2. 2 is the number of movement lah. I just note here the number of movement. Okay. And then we settle it down and find out the binary for for the exponent. And then sign is simple. If the number is positive, sign is 0. The number if the number is negative, so as is 1 lah. And then because number is positive, if I put the note here, if the number is negative, S is equal to 1. Okay. And then fraction. So fraction, we just take the number after we move the titik perpuluhan to the front. Here, 0101, blue here. And then I paired up with more zeros here because I want to make 23 bits. Overall, 23 bits for fraction. So until here, okay, sepatutnya dah lega lah because you just need to arrange the sign, exponent and fraction into its place. So dia akan dapat macam ni lah. Sign 1 bit, exponent 9 bit, while fraction 23 bits. So overall is 32 bits. So this is the answer of 5.25 in floating point or IEEE 784. Ni jawapan dia. So to check, or to if you want to return back to the question, means from binary to decimal, you have 3 formulas that you can consider. Depends on the exponent value. So here the exponent is 10000001. If you convert to decimal, you will get 1 to 9. So 1 to 9, the formula that you can choose is the first one lah, because the first one exponent between 1 to 254. So we use this the first formula, okay, and then we write it here, and then we just replace the value. S is 0. We know from top here S is a 0, and then from here S is 0, and then 1 dot fraction. Fraction is this one, the blue one. So you see 1 here is represented by 0.25 and 0.0625. You take the value from the table above, okay, and then exponent is 1 to 9 lah. Okay, this one is the brown one here, the gray one is 1 to 9 minus 1 to 7. So anything that we power with 0, we get 1. Okay, and then here this one, we get 1.3125, and then times 2 and power of 2 lah. And then we do like normal, and we get back the answer, which is in decimal. So that's it. Itu saja. Okay, agak penat sikit petang ni, but never mind. Minggu depan kita cuba untuk habis kelas cepat lah sebab bulan puasa kan. Tak larat nak cakap panjang-panjang. So any question nak tanya apa-apa? Ke semua orang dah tidur?
Tak ada, doktor.
Kesian tak apalah. Saya pun tak lapu sangat. Pemela okey?
Sir can send this file in group.
Boleh. I baru nak buka WhatsApp sekarang.
Okay, thank you sir.
Sama-sama. Lagi? Atau apa nak tanya ya, sebab dah pening ya? Sekejap saya hantar ke WhatsApp sekejap. Saya takut lupa. Sementara tu apa-apa nak tanya? Minggu depan kita habis. Ya?
Cuba dia ulang tak yang part 0.25 plus 0.0625 tu, tengok kat mana tadi?
Yang sini ke? Ke yang atas lagi?
Yang bawah tu.
Yang bawah ni fraction kan? Ni fraction, yang ni dapat dari formula. We got it from the formula, or from the formula lah, formula fraction So how to get this value? So we refer to the answer just now. The answer here, fraction is 0101. See 0101. The rest is 0. So just ignore it. So 0101. If you want to convert to decimal, we need to refer to the table just now. 0101. Mana table ni? 0101. 0 1 0 1. So 1 is 0.25 and 0.0625. So add these both numbers. Tambah dua nombor ni. Jadi bila tambah dia jadi macam ni lah. Dia jadi macam ni. 0.25 tambah 0.625. Dapatlah 0.3125. Yang satu ni, I just copy it from here. Just copy it from here. Dapat tak? Ke tak faham?
Faham.
Lagi dekat mana tu je lah. Yang ni tadi jangan lupa untuk fraction. Okay, take it from here and then just add up with more zero. Your objective is to make it 23 bits. Okay, sign is just just look at the number. If the question is positive, so S is 0 lah. If negative, S is 1. Exponent, we just take it from exponent's formula. Exponent minus 1 to 7 equal to the number of movement. After you move the point to the front, how many movement that you made? In this case, we made 2 movement, 2 steps. So equal to 2 lah. So how to move it? Okay, you just move the point to the front until you find the first one in the number. So in this case, the first one is this one lah. So you need to step to jump 2 times. So equal to 2. But okay, this is the example. Let's say the point here is here. So how to jump? So just jump 1, 2, 3, 4. 1, 2, 3, 4, 4 times. So it become like this. So this is what I mean lah. So this one is a fraction lah. Fraction So just add up with more zero to make it 23 bits. So for this one I already noted here. So power of 2 means 2 times 2 step forward. You just move 2 step, and the big 2 here is represent base 2 base 2 numbers So dekat atas ni semua sama lah. Ini yang warna orange, the orange color is similar like if you want to get the answer in fixed point fixed point. So this is the technique lah. Yang atas ni tadi fixed point this one fixed point. So ni nak check ni macam biasalah. Oh ini pun sama juga, kita guna 0.5 dengan 0.2 jadual yang kita dah buat tadi. The table that we just create just now, we use it also at this step, which is if you want to convert the number before titik perpuluhan into decimal So yang atas ni sama, fixed point, itu saja. Yang ni tadi nombor tadilah, hexadecimal, octal, binary, decimal. Itu saja. Okay, ada soalan? MTN. Okay. Jangan risau, minggu depan kelas kita habis awal sebab saya pun tak larat nak cakap panjang-panjang. That's why I all out sikit minggu ni Mana tadi? I just want to send the file to you. Wait a minute. Arithmetic note. Okay, I already send it to apa nama? WhatsApp Okay, ada apa-apa soalan lagi? Eka Hairina?
Tak ada, Doktor.
Tak ada. Okay, tak apa. Just refer to the notes. Kalau tak faham, tanyalah dalam WhatsApp Okay, for international student, I hope that if you have any question, please ask me through WhatsApp. Okay. And the notes I already send it through WhatsApp group. Okay, that's all for today. So I'm very sorry because it take a very long time to finish up this section. But never mind. For next week, I'll try to make it finish as well as possible, as soon as possible lah. Sebab Ramadan Okay, Assalamualaikum.